Alright, this is another bonus video for 4.3 dealing with definite integrals, and we're working out a piecewise function. So I'm given f of x to be this weird looking piecewise function, and I want to find the value of this integral. So first of all, I have to sketch what this looks like. So it looks like it's going to be a straight line before it gets to 2. So this has a y-intercept of 3, 1, 2, and 3, and it has a slope of 1, so I have to go up 1 over 1, and it's going to go another up 1 over 1, and it's going to be a straight line this way. It's going to be a closed circle because it's defined to be the straight line at 2, and after 2 it switches over to be negative 3, so it's going to go negative 3 until it gets to 4. So there's going to be a straight line from negative 3 to 4. And it's going to have an open circle on this end and a closed circle over here. And then if I want to sketch, just for the sake of continuing this graph, once it gets to 4, it's going to have a slope of negative 1. It's going to go down 1, over 1, down 1, over 1, and then down 1, over 1 for this piece of it. And the way I found this is I just took the limit as x approached 4 from the right. F log in 4, this is going to give me negative 4 plus 7, which is 3. So at 4, the value of this line is at 3. Alright, so that's what the graph of f of x looks like. Now if I want to find the area from 0 to 4, that's going to be talking about kind of splitting this up. Is at 2 there's a split, so I have to find the area of this trapezoid and then find the area of this rectangle. To find the entire integral. Alright. And so this is the same thing as going from 0 to 2 of this function, and then going from 2 to 4 of this. So I have to find the integral piece by piece. So let's call this this trapezoid A, and this trapezoid has a h of 2. So 2 over 2. This side has a measurement of 1, 2, and 3. And this side has a measurement of 1, 2, 3, 4, and 5. So it's going to be 3 plus 5, which is 8. Now for this piece, for B, let's label this A and this is B. For part B, it's just a rectangle. The base of it is 2. The length of it is 3, but because it's below the x-axis, it's going to be a negative, so it's going to be negative 6. So this becomes 2. So that's what my integral value is at 2. B, for part B, find the value of this integral. Notice that the limits are not in the correct order. I have to have a smaller limit on the bottom, and I have to have my bigger limit up on top. So it's 4 to 7, so I have to switch them. And the integral property says that if I go ahead and switch them, I need to factor out a negative sign. So this negative factors out. And I'm going to be looking at the area from 4 to 7. So that's going to be conveniently where this graph stops, where it hits the x-axis. 1, 2, 3, 4, 5, 6, 7. Yep. Alright, so this is just looking for the region C. So this region C is just a triangle, which is 1/2. The base of it is 1, 2, and 3. The height of it is also 3. So 3 times 3, which is 9, times 2, so it's going to be 9 over 2. But since I factored out a negative, it's going to be a negative 9 over 2, and that's my integral value for part B. And that's it for the bonus video.